Hello everyone, I am Paromita. I am pursuing PhD in physics at IIT Kanpur. Today I am going to solve some problems related to dry friction. Before I start solving this problem, I suggest you to solve as many problems as possible. Please go through Professor Herbola's book and solve all the example problems that are based on belt friction, rolling friction, the friction between different bodies, inclined plane problems, etc. Today I have selected some problem from assignment number 3. So, I start with the problem from assignment number 3 and which is problem number 1. So, problem number 1 in assignment number 3. So, you have seen in your lecture notes, in your lecture series of week 3 that we dealt with dry friction, where we have seen that if I increase the force, suppose there is a body here and it is on a horizontal surface, I call it x direction and I call it y direction. So, suppose I have applied some force F. So, the friction between these surfaces will increase accordingly. So, if I plot frictional force as a function of the applied force, the frictional force is proportional to the applied force. So, it will increase to some limit, say F max, till we reach this F max. Frictional force is linearly proportional to F. So, I call it Fs equal mu s times n. After this reaches this maximum value, then it does not increase, but it actually saturates, and this corresponding to this maximum force we have Fs max, which is mu s n. So, the frictional force is less than equal to mu s n. We will use this idea in solving some of the problems. So, in this problem number 1, it says that there is a triangular block on a horizontal plane. This block makes an angle 30° with the horizontal, and the coefficient of friction between these two surfaces are given as mu, and I take this direction to be positive x. So, this is my positive y. Now, a force is applied at an angle 90° with the inclined plane. So, inclined plane makes an angle 30°, and at an angle 90° I apply a force, say F. Now, the question is, what is the value of F max that is applied perpendicular to the inclined plane so that the block does not move. That means the frictional force will balance the force component so that the block will not move. Now, I have to find the forces along x and y separately. I have to take the components and then I will use summation of f x equal to 0 and summation of all the forces along y is 0, and then from there I find the equation to find out the maximum applied force. Let us see this once again. So, this is my triangular block making an angle 30 degree. This is x, this is y. Force is applied at angle 90 degree. So, it is like this. So, I can just redraw this force like this here for simplicity. So, this is my y direction. This is minus y, this is plus y, this is plus x, and this is minus x. So, now if makes an angle, if this is 30 degree, so f makes an angle 30 degree with a negative y axis. So, I can write summation over f y equal to 0 as, now you see the block is right here making an angle, this inclined plane makes an angle 30 degree. So, mg is like this downward, and the normal reaction from the surface is n along the positive y axis. So, normal reaction is this way, mg is this way, and the force has a component f cosine theta along the negative y axis. So, if I write this summation of f I equal to 0, I get n along the positive y direction, I get the minus mg because it is along the negative y direction, and then I get minus f cosine of theta because it is also along the negative y direction. So, I get this to be 0 from here, or I can write f cosine theta is n minus mg. This is my equation number 1. Similarly, from f x summation f x to be 0, I can find out the forces along x direction. So, what are the forces along x direction? I can see from my diagram that if f has an angle here as 30 degree, so along x direction the component will be f sin theta. Now, the body tries to move this way, so the friction will start acting on it in a opposing direction, that is in the negative x direction. So, the frictional force will be this way. So, I write the frictional force Fs in the negative x direction, and I know that the force has a component along the positive x direction like this. So, we have this equation for all the forces along y axis. Similarly, we have all the forces along x axis, which is this f sin theta along positive x direction, and minus Fs, which is, I have taken it to be minus, which is along negative x direction. So, now when I write summation of all forces along x axis to be 0, I will take f sin theta, which is along the positive x axis. So, f sin theta minus this frictional force along the negative x direction. So, I take a minus Fs equal to 0. So, from here I can write Fs is f sin theta. Now, we know that the maximum frictional force possible is Fs equal to mu s times n. So, I know that Fs is equal to mu s times n, and from here I can write n to be f cosine theta plus mg. So, I get n equal to f cosine theta plus mg. This I obtained from summation over all force along y to be 0, and I got f sin theta equal to Fs, and I got Fs equal to f sin theta, which is from summation of all forces along x to be 0. So, now using these two equation and knowing that Fs is less than equal to mu s n. So, the maximum of frictional force, maximum frictional force is actually mu s times n. It cannot go more than this value. So, you see from here this graph, this plot that I have shown. So, this is this Fs, the maximum value of Fs corresponding to the maximum possible force. So, now if I write mu s n in place of Fs, I get mu s n equal to mu s, taking the value of n from here, f cosine theta plus mg, and which is nothing but f sine theta 1 and 2. So, this I got from 1 and 2. So, I take everything in terms of f. So, I get f sine theta minus mu s f cosine theta equal to mu s mg, or f is equal to mu mg by sine theta minus mu cosine theta. So, the maximum force, this is the maximum force, because Fs I took as maximum. So, F max is equal to mu mg divided by sine theta minus mu cosine theta. So, that is the maximum force to be applied so that the block does not move. So, that completes the first problem. So, now we move on to the second problem, which is the problem number 9 in assignment number 3. So, in this problem, this problem is taken from Professor Herbola's book, and you have solved this problem in assignment number 3. So, I have an inclined plane which makes an angle 30 degree, and I have a block So, now the weight of the block is given, which is 500 Newton, and a horizontal force F equal to 800 Newton is being applied to this block. Now, this block tries to just about to move up this inclined plane. So, as you know that frictional force is always there to oppose the motion. So, I have the block about to move upward. So, the frictional force will be downward. Okay. Now, the question is, we need to find out mu, the coefficient of friction between the contact surfaces, that is between this block of weight 500 Newton and this inclined plane. Inclined plane makes an angle 30 degree. Like before, we will resolve these forces along x and y axis, and then we will apply summation of Fx equal to 0 and summation of Fy equal to 0 to find out the correct expression for mu. So, now if I look at the forces, before that I take this to be my x axis. So, perpendicular to this inclined plane, this is my y axis. Okay. So, if the body tries to move up, so force, the frictional force Fs will work along negative x axis. This is the weight, it is downwards. So, the reaction from the contact surface is N, which is along positive y axis, and if this is 30, this is also 30. So, there will be a component mg cosine theta or 500 cosine theta Newton along the negative y axis. So, I have 500 cosine theta this Newton along the negative y axis. What else? What other forces I have? So, I have a minus mg sine theta along the negative x axis. So, I have mg sine theta along the negative x axis, I should say. So, I have 500 sine theta along negative x axis, and the normal reaction from the surface is along positive y axis, and this force is in the horizontal direction. So, it will have a component of f sine theta, or I should say f sine 30 degree, because theta is in this case 30 degree along the negative y axis. How this force has a component along the negative y axis, let us see. So, this is now my x direction and this is my y direction. So, you can see F is applied horizontally like this. This is the direction of F. So, F makes an angle (30° with the negative y axis. So, taking all the forces along y to be 0, I get f sine 30 along negative y direction minus 500 n cosine 30, and then another force which is the normal reaction, which is this way. This is f sine theta, this is n, and we have mg cosine theta. So, mg was like this. So, mg cosine 30° is here. So, these are the two forces and this is the one force. So, we have three forces. So, this and we have plus n, this equal to 0. So, let me erase this part so that I can write it on this same page. So, this is the equation for the y component of forces, and this gives me n is equal to, from here F is 800 Newton. So, I have 800 here minus 800, and sine 30 is half. So, I get 8 minus 800 by 2, and then I have minus 500 Newton. So, I have 500, and cosine of 30° is root 3 by 2. So, I write root 3 by 2 here. This is equal to my n. So, this is positive. I take n this way and I take the other things the right hand side. So, I get n equal to this plus this, and I obtained 400 plus 500 root 3 by 2, which gives me the value of n as 833 Newton. So, I obtained the normal reaction from the contact surface and the value is 833 Newton. Now I have to find out the frictional force as well. So, let us see. So, let us look at the forces that are acting on this along x direction. So, summation of all forces is 0. So, now I get the frictional force F is equal to F cosine 30° minus 500 Newton sine 30°, and the force is 800 Newton, that we already have seen here. The force is 800 Newton. So, I write 800 cosine 30 is root 3 by 2 minus 500 sin 30 is half, which is equal to 442.8 Newton. So, now we know that the maximum frictional force F max is mu times the normal reaction. We have already found out the normal reaction to be 833 Newton here. So, we use this value and we write this to be 833 Newton. So, now the coefficient of friction is F by N, which is 442.8 Newton divided by the value of N. The value of N is 833 Newton. So, I get the coefficient as approximately equal to 0.53. So, that is the correct value for the coefficient of friction. So, with this we complete the assignment number 3 questions on friction. Thank you.